저희가 오늘 지금 이제 진행할 패널 세션은 영어로 진행할 예정이에요. 왜냐면 이제 한국어를 못 쓰시는 분들도 있으시니까 영어로 진행할 건데 저희가 지금 세션 녹화는 하고 있으니까 나중에 한국어로 서브타이틀, 그러니까 자막들은 달아서 나중에 아마 배포할 예정이어서 그거 참고해 주시면 될 것 같고요. So I'm gonna start speaking in English. Hi everyone. How's everyone?
Nice to meet you.
Hello.
Nice to meet
Thanks for
you.
having.
Hello.
So, I gave you guys the question list, and yeah, you guys can share. So, we all know that the title of this Hacker House or the event is called Privacy Hacker House, but some of you might know that privacy is not very favorable in context of Korea. I mean, for example, Monero is recently delisted from Korean exchanges. And well, not only in Korea, but just in general, well, Tornado Cash, the developer, has been charged with AML and anti-money laundering and all that kind of stuff. So we are here with all the different panelists who are working on privacy to try to explore what all these means and whether privacy actually means something or what kind of potentiality there is to it. So, well, let's start. So the first question that I'm gonna go over is, I'm just gonna go over one by one. Could you explain who you are? I mean, we've been talking for a while, but who you are, what you're working on, and briefly explain yourself. Would you want to go with it?
Yeah. My name's Kyle, or Taproot, I guess, on Telegram. But I'm the DevRel at Fhenix, and we are building like an FHE L2. So basically allows you to build in like private encrypted fields in your smart contract. So if you're interested, we're going to be sponsoring the track at ESOL. So yeah, let me know if you're interested.
I'm Daniel. I help out the ecosystem at Aleo, but I primarily focus on some of the infrastructure side of things with validators, the ZK miners, and help out on like some of the institutional BD work and APAC.
Yeah, I'm TA. I'm from Kroma. I'm a ZK engineer on the team. We're the first optimistic rollup with active ZK fault proofs. And our team's current mission to move on to ZK rollups is definitely like reducing the cost. Especially we're focusing on hardware acceleration and modularity. And yeah, thanks for having me.
So it's exciting. As I was explaining in the very opening, privacy is not taken in a favorable light at the moment. But since the focus of this topic is privacy, so I guess our first question is to ask ourselves, what is privacy, and what is the importance of privacy in context specifically to Web3? Is it important? If so, why? I guess this is open. This is an open question. So this is like more of a Texan, like shoot each other, takedown style. So whoever want to go first, go first.
Maybe I'll start off this. I think privacy in Web3 is important. Well, basically, if it's not, I think it's not different from Web2, I think. Like, that's one of the definitions or like the features of Web3. But I think all the stuff's going with Tornado Cash or like Monero delisted. Those kinds of regulations make people have a misconception that privacy is something for like hiding some like illegal stuff or something. That's what's making it favorable, I think. But the importance of like the privacy in Web3, I think, is preserving. So now the problem is what to preserve. So for Tornado Cash, they were preserving transactions, which led to kind of like potential money laundering and stuff. But for me, recently, I came up with this very, very interesting case where Tornado Cash I really think is needed is maybe I'm the owner of the company and I'm trying to incentivize my teammates with tokens. They can see them all on the maybe either scan or something, how like someone's getting how much.
Yeah, you see everyone's paycheck.
Yeah, then we can retrace it and like see, and like there might be some halo in the company. So I think it's about like what to preserve. So if currently I've seen like many projects currently working this year on ZK credit. So you're basically doing KYC, but without revealing all your information. So in that terms, I think it's definitely important. It has to come to us. Yeah, I don't know when, but maybe this year some of those like ZK credit or something might be the breakthrough.
Yeah, we'll go down the line. I think privacy in the context of blockchains or public blockchains should have always been the default. I just don't think that when we had blockchains or decentralized blockchains come out, we had the technical capacity to do so. I also think it's the reason why privacy or the need for privacy at default is so important is because a lot of how some of these public and transparent blockchains had been built initially had assumed that users of those blockchains would interact with those blockchains or act on those blockchains in a particular way. I think very specifically, even with Bitcoin, right? The common the initial assumption was that you would have new addresses or new accounts for each transaction you did, right? Because you have this. It's the reason why. And I know anonymity is not necessarily privacy, but like we had this concept of like pseudo anonymity. Yeah, you're not going to know my name or my address, but you'll have like these different types of accounts that you can potentially see or trace back. But it should have been new. It's the same reason why I think I gave the example with like, you know, if you have a seed phrase, you can generate technically almost an unlimited number of accounts with that, and you're supposed to use all those different accounts for. Right, but that pseudo anonymity is actually. I'm not saying that most users are not educated enough, but they're not following the way that the system had been designed.
Yeah, the original purpose. Yeah. I guess like due to the convenience purposes, like users tend not to.
It's like there's this. Yeah, so they were supposed to use it a certain way, and I feel like these engineering types had like this concept, okay, this is ideal, but the reality is users are not, right? They don't, right? You can even, like, users don't even care about the technology, right? They just want like their
Pepe
coin
to go cheap and easy.
Yeah, and then that's why I think, right, it has to have been default, right? This technology should have been defaulted, right? Privacy, whatever, permissionless, decentralization, because the reality is that the majority in this type of mass adoption, people are not going to choose that if it's difficult. Same reason why the majority of Zcash transactions are all unshielded. It's defaulted, but then you have to go out of your way and pay more money to have the private transactions you want. So TLDR, I think privacy should have been default. I think we're only beginning to see the full potential of what a decentralized, right, public blockchain can have with these like privacy preserving technologies, privacy with programmability, even like FHE, right? Like FHE is like the holy grail of a lot of cryptography, right? So yeah, it should have been default. Now I think we finally have the technology, the hardware that we can have to accelerate and make it cost efficient, et cetera, to do that.
Yeah, I think that there's another important distinction right off the bat is there's a difference between privacy and anonymity. Like sometimes it's okay. I mean, I think both are important and both should have their place. And some would argue that privacy/anonymity is, it's a necessary building block of security, freedom, like just being able to go by your life, right, with a peace of mind. But and I think that, generally speaking, sometimes large entities tend to kind of classify everything together, whether that's for like ulterior motives or for whatever reason. And so that's why I think, at least in the scope of like this technology, it should have been included by default in its inclusion. But Obviously, there are issues where if you want to add noise, for example, right, that's by definition going to be more expensive because you're adding buffers and stuff around it in order to obfuscate the truth. That being said, I think that privacy isn't something that's just going to naturally just happen. It's going to take a lot of different people trying a bunch of different approaches over time, and then providing that technology and the opportunity for the average person to actually use it.
I also want to add on, like, you talked about Monero, and I think that's such an interesting use case on privacy, because Monero, I think, ideologically followed the privacy path, like, as best they could, right? They're like, we're not gonna like unshield, or we're not gonna like provide these things, and then centralized exchanges are like, okay, you're gone.
You're out.
Yeah, and then right, it's like very little liquid. I think they're still listed on like KuCoin or Gate and MEXC, but like, I'm not saying that in order for us to have truly ideologically sound privacy technologies, we have to like give up certain properties, because the privacy stuff is compliance. And then you get into like, are you messing with North Korea or Iran or like, all these folks?
Yeah, anti-money laundering. And,
yeah,
well,
but I think like, so I had worked a lot in the infrastructure provider space, like with validators. Maybe validators should have all been anonymous from the beginning, right? Because like the business model is everyone has to differentiate, and then they have to seek delegation, so they have to specialize. And they can't just be these commoditized pieces of infrastructure that could be run anywhere in the world, right? And then you get that type of, but I don't think also validators, they don't want to like be constantly on the run from governments, right? If they truly believe in the mission of, let's say, like Monero or running a node there, et cetera, they're not going to go live in a cave with like a computer strapped to their back, like sending signals up to space. If they truly did follow this so-called like cypherpunk ideology, they would. But then the reality is we all live in a country, and each of these countries have relationships with other countries. They have laws that they have to obey. And so I think like I wouldn't necessarily say like the delisting of Monero from centralized exchanges is necessarily a bad thing, and then like privacy has failed in that regard. But I think it's privacy projects now have the ability to complement traditional or existing regulatory regimes, so that we just don't get taken over, right? Because it's not like a matter of like we're playing in our sandbox and then the regulators come and say, okay, we're the adults, playtime's over, show us what you've done to protect our citizens from like getting hacked by North Korea, and then we have nothing to show for it. I think it's an opportunity for us to build like these compliance policies, regulation, and that can all really happen at like the technical level, right? View keys, graph keys, whatever you need to build on that regard. So yeah.
Yeah, I guess one of the analogy that I heard was like, I mean, let's say Monero's like a darknet. Well, it's not perfect analogy, of course, but let's say it's a darknet. But I mean, darknet's gonna exist within context to internet. But as some of the things that I've heard was that, I mean, internet is cryptographically secure, like SSL, TLS. I mean, that's like default by which like we some of the messagings are concealed, and that's how we conceive internet as a secure protocol for messaging layer. And then like in a way, I thought, to my mind, privacy network is kind of promoting that regime or that step towards another security and enhancement within Web3 technology. And that leads me to the next question, is because like, since you guys are all working on a different kind of like technology at the moment, I mean, Aleo is centrally focused on, primarily focused on ZK, Fhenix is focused on FHE, and there's MPC messaging, and but Kroma is working on more of a ZK hardware technology. So could you explain like how all these like different like, I guess, components of privacy technology are like within context to the landscape, or are they like mutually exclusive, or will they like merge into something else, or like for the enhancement of technology, how do you think they're gonna cope out in the future?
I actually like had like this similar question a week ago from my other developer friend in the blockchain scene. So I actually, he wanted some motivating examples behind like ZKP, FHE, MPC, all those stuff. And I've actually written down like a bit like for each scenario.
Is it a poem? No.
No, it's more of the text side. So I'll go one by one. So ZKP enables one party to prove the other that a statement is true without revealing any information behind the validity of the statement itself. So let's say a user probably wants to like prove that they're over like 18 to access a certain content, but without revealing that their exact age or date of birth. Like when we maybe try to like buy something like liquor or something online, I'm not sure if it's possible online, but like we have to like do all those like phone verification and stuff, give our like birth of date or something. But with ZKP, there's a way that we can like hide the witness, but prove that I'm over 18. And for FHE, I'm not an expert on like FHE MPC, but
Here's
like,
expert. He's gonna correct you if there's something wrong with it.
tell me if I'm wrong. FHE allows for computations to be performed on encrypted data, producing an encrypted result that, when decrypted, matches the result of operations performed on the plain text before it was encrypted. So one motivating example I thought was like, maybe a health research institute wants to analyze patients' data from various hospitals to study some like very, very unique disease. But like it wants to like pattern without like compromising the patient's privacy, right? So with FHE, the institute can like perform this analysis on encrypted data. So the hospitals will like encrypt their patients' data and send to the research center, and then like they'll perform some computations on it, decrypt the result, and reveal the insights from the analysis without then exposing like any patient data. Am I right? Okay. Last, MPC. So it's multi-party computation, right? So it definitely involves multiple parties jointly computing a function over their inputs while they're keeping those inputs private. So this facilitates to like collaboratively like do data analysis, but without like revealing their some data they want to hide. So one motivating example I thought was like several maybe retail companies, they have a group and they want to like collaborate to understand the market like trends without revealing their market like information, like because they're fearing of like competitive like disadvantages. So using MPC, they can compute like the average sales performance maybe in the market without like any single entity having to reveal its like individual data. So each participant like contributes to the encrypted data, and then like the computation, after all parties joining the computation, then they'll yield like only the aggregated result, and no one can like retrieve like sensitive information from the aggregated result. So I think I haven't seen like these maybe like 2 or like 3 jointly combined to do something, a project to do something, but I definitely think they are not mutually exclusive, and they can be integrated in some way, maybe like now then like expanding from these examples, like maybe multiple groups might want to, and then maybe like insurance company, they're trying to like offer you a loan, but like all these different industries have their different rules. They decide to like give him a loan or not based on their like credit points or something. And then like maybe I wanted to get a loan, but they refused to, and I want a proof from them. Then they can do like ZKP stuff like to give me proof like why, like we're not revealing our like private information, why we came to this decision, but like they can like try to like persuade me with that proof or something. So I think maybe it's possible to like do all these stuffs at once, to do like some funny stuff and something, make it transparent but private. That's my take.
So I am a example of having used all of those combined. Maybe not the MPC, but I was like I used to do bioinformatics research for about 5 years, and we were doing distributed system stuff there. But right, I think the healthcare example was exactly so. Like we were doing gut bacteria research, and we had like a bunch of different labs that had their own gut bacteria data. But the thing with gut bacteria is that it's literally poop, right? You get your data from poop, and it's expensive to get that poop data, right? There's like stool banks.
So shitty.
And so each of us, right, wanted to aggregate all this data together, put it into like a pile, all this poop data into a pile, and then work on it. But then the problem was it was expensive. It was our data. We didn't want to give it away. And also maybe other labs had, you know, shittier other data. But like, and so we used FHE. We were like, FHE is FHE was pretty slow back then, but time wasn't really like, we didn't need it like immediately, right? We can wait for a week or whatever. And so we used FHE to basically encrypt all our data and run computation analysis on it, which is great. The problem that we had run into was that each of us, how did we make sure that each of us was actually providing real data? Or like, what if it was like not, right? Maybe my data was pristine and great, but someone else is just putting like random stuff in there. And so yeah. And so what we actually did was we used ZK, right? We had to use ZK to prove that our data had certain properties. Everyone had used ZK to say, okay, my data has this, and this. My data has this. And then we ran the FHE. Then everyone was confident that the data was up to a certain par. And then we were able to run the FHE. So I think it's like ZK was a step to get like FHE. Because like FHE is like probably one of the most important like technological marvels that we can have, right? Like it's incredible, but then ZK was also important for like the steps to it, to that. So.
Yeah, I think that's a really good point. Especially there are some methodologies in terms of kind of what you're saying, using like a ZKP to prove that something is formatted correctly, right? Like even in like certain FHEVM implementations, right? Like a zero knowledge proof of plain text knowledge can be used to verify that whoever's constructing the ciphertext actually knows the value of the plain text, and also, yeah, like you're saying, the plain text or the ciphertext is actually formatted correctly instead of just sort of could be gibberish that would throw off the whole system. But yeah, I definitely think that there is a lot of overlap and ways that the technologies can be combined. Especially when you think of FHE, especially FHE in practice, especially when you think about in terms of a blockchain, right? Like it's good to have some sort of threshold decryption service, or else FHE is kind of tricky if you can't really figure out who's able to decrypt when. So that I think is where the multi-party compute definitely comes in. And you know, especially as it pertains to FHE and ZK, I definitely think that there's a lot of different avenues that can be explored because, you know, as it's been stated, FHE is notoriously slow and expensive, but hopefully, you know, over time it is improving at a pretty, you know, an optimistic pace, I would say. But I think that, you know, for me, I think that one of the main benefits that ZK provides the world is succinctness, right? Like we can quickly verify things that happened and the scope of blockchain, we can quickly verify this happened on chain. So I definitely think that there is a way that these technologies can be combined to sort of help scale FHE, put simply.
Wow, that's very interesting. I mean, I'd like to see all these like technologies merging into one another so that like one of the core pillars of privacy shed into a light. But as of now, like we're still confronting a problem that, as you're saying, like users want for Web3 to come to a mass adoption. Users want, you know, readily available products, like readily usable, fast, cheap, and like something that can be like tangibly convenient, for example. But to my mind, maybe I'm just too much of a normal person to think about it, but it seems like to me ZKP and FHE and the privacy technology is still at its primitive stage to be fully adopted in terms of like Web3. So like the way in which I think of it is like Ethereum was conceived like, you know, 2013 when Vitalik was just pissed off. You were talking about it, trying to fiddle with the color coin and stuff. And then it was, you know, it came out in 2015, but it wasn't until like 2020 or 2019 that Uniswap was actually used that decentralized application in its even in its primitive form was shaped, that we could see that Web3 or like dApps can actually have a potential. So to me, it seems like ZK and the FHE at its right now stage seems like 2015 of Ethereum. Maybe I'm wrong. Please correct me if I'm wrong. So what are the potential like use cases that you think could be like available in the future that you guys are all expecting, and how long of a time frame should we expect that to happen? Well, we can't be sure about like, well, we're not throwing stones in a sky to make the predictions, but just to get the gist of the ideas.
Maybe I'll go first again. My take on like maybe the ZK killer app or something maybe will come from what I said before, like on the credit side. Maybe like I've seen some like interesting projects doing like ZK KYC something, because it's definitely my personal opinion, but like I really didn't want like the bank knowing all my stuff, like where I live, like how old I am, like how much income I have and stuff like that. So also like to the centralized exchange and stuff, they know all my stuff, like how much I'm like buying Bitcoin, like Ethereum or something. So probably on that side, or maybe it's like similar, but like voting side, I think, because we want things to be transparent, but like fully private, like, but still we know the result of the voting, right? Who won or who lost, but they don't know who I voted. So
Shout out to Punkpo, I guess.
yeah. So so maybe those two applications I'm thinking, I'm really chilled with those two projects, those two types of projects. The time frame I think will be within a year. I think if those two projects.
That's very ambitious. Within a year.
Yeah, because they don't have to be like really like time competitive, I think, because we have like a day to vote or something, so right, and I think it's ready, but it's the problem of like how to get to the users, like hiding all those like technological stuffs that comes as a barrier for users. But I think the tech is ready, so probably a year, like fixing UXs or like making it to a tangible product. So I'm kind of bullish this year.
Optimistic.
Yeah, I would say there's like two things that I think of when you ask that question. One is private payments that have programmability, which we had private payments, but we didn't have programmability. I think that's definitely probably one of the more important to me, like killer apps. It's simple, but then we haven't had that level. Like blockchains sometimes provide that type of composability. I think that's one, which is maybe as soon as Aleo launches, right, or any other ZK one.
AlphaSwap I think left, but like they're doing some of it. So
yeah, the other I think is much longer time frame. I think hardware. I think you were mentioning. I think hardware acceleration is probably one of the most exciting and important parts that specifically cryptocurrencies, not just like blockchains, but like the reason why sometimes cryptocurrencies exist is so important. And what I mean is that, right, for example, for those of you who are familiar with the Bitcoin space and Bitmain would not exist and would not have had the ability to produce all this such specific and efficient hardware that is capable of, right, doing proof of work. I think because these blockchains like Aleo, these ZKL ones like Aleo or some others that also do things exist, there's this incentive now that is tangible money that can go back into R&D to develop these. And as you were saying, right, like it's not just Web3 specific applications, but right, even this was like almost 10 years ago when I was working in this lab, we were using it back then, and we didn't even use a blockchain. But then, right, if there's incentive for, let's say, ZK miners as what I would say is like this brand new third infrastructure class, POW had miners, POS you had validators, and now we have ZK miners. They are now able to develop efficient hardware that is capable of addressing needs beyond Web3.
Money moves people.
Yeah, exactly. But like, it's the whole like, good behavior has to be incentivized. It's not. No one is doing things. Bitmain's not building these specialized ASIC, and they have over 90% of the Bitcoin ASIC market, right? They're not doing it out of altruism. They're doing it because they make money, and then they're able to make that money and then put it back into R&D to make more efficient hardware. So I think ZK hardware infrastructure, I think, is definitely has this like catalyst, especially in the cryptography field or crypto engineering field, that blockchains and the cryptocurrency aspect of blockchains specifically has like revitalized, because right, ZK's been around since the 1970s, right? And then it's been like 30, 40, 50 years almost, and now we're having this ability to just like kickstart it. That's why like AMD is one of the co-sponsors of Z Prize, right? This like sort of like industry-wide open source contribution bounty program or a hackathon thing. But yeah, I think hardware is going to much longer time scale. But then if we're incentivizing the development of that because there's actually money coming in to support the hardware manufacturers.
Yeah, I like to think about it sometimes, at least in the scope of FHE, at least, that we're sort of in like the pre-ASIC days. You know, like if you go back to wherever Bitcoin was before, people were still doing it on like bootleg
Mining
machines.
out of laptops.
Yeah,
those
exactly, in
days.
someone's basement. So it's
PC
kind of so I think that there is, at least there's a lot of incentive from like federal institutions such as like DARPA, et cetera, to invest in FHE hardware acceleration. Maybe not so much for like the specific composability of the private state, but at least the lattice-based cryptography schemes that it's built on top of are supposed to, afford a different approach, I guess, to quantum proof computation and state management, et cetera. So from that perspective, I kind of think like I hate saying this phrase, but it's almost just a matter of time, right? Because like if you have that large of an entity putting in resources and it's motivated to do that, I think that's a very bullish indicator. I think in terms of like ZKP, in terms of building private applications, I definitely think that there is a hardware constraint aspect to it that can always be optimized and fixed, et cetera. I do think that there are other limitations in terms of like what could be constructed in terms of like, for example, like voting, right? Like if you want to be able to run a state transition and a state transition and another state transition from the output of, what was basically constructed on the client side or some sort of like single party, construction state, I think that might have to either require some sort of pivot in general or a new approach. But I think that's definitely a very promising reason for overlap, right? Because I personally do think that ZK has the potential to really help scale FHE in a bunch of different ways. And in terms of like the killer applications, right? Like I suppose your guess is as good as mine. Some would say DeFi, some would say voting, governance, etc. I do think that especially at Fhenix, we are working on building sort of like this FHE core processor narrative, which is sort of using Fhenix as sort of like the general layer for encrypted computation, whether that's like, cross-chain stuff from something like Base or another network, so you can actually still maintain the liquidity and the network effects of other networks. And again, that applies to ZK networks as well. But if you ask me personally, I think probably one of the bigger killer things to break into the mainstream, other than like the whole blockchain store of value thing, is probably going to be like FHE machine learning to some degree, because as AI is becoming more ubiquitous in our lives, I think it's pretty obvious that's not going to stop. And especially once we have like robots, I guess, in our house, like doing dishes, etc. Right? You want to probably make sure that like that information's not getting leaked, or if you're trying to sell energy to the grid, etc. There's like 1,000 different sensitive use case informations where you probably don't want your input to some sort of model that's going to have some jurisdiction over your life, right? You don't want that to leak information anywhere. So whether that's having the ability to train something over an encrypted data set, which I think opens up new avenues for user data in terms of like what is valuable, right? Can we actually achieve some sort of like post source like I guess like UBI world where like people are just, we provide value and keep the world spinning and the wheel spinning basically just through the data that basically helps make things more efficient. But I think it's an exciting future, and yeah.
Yeah, I think well, that really discussed like the potentiality. Well, to summarize it all, money's coming in, time's short. It's something's gonna come, and we can't really be sure like what's gonna come. But I'm also really interested in the the listeners, what they some of the questions that could be raised to the panelists. 그 이제 질문을 받을 예정인데 한국어로 질문하시는 분들 같은 경우에 제가 영어로 그 패널리스트 분들께 질문 드릴 수 있으니까 편하게 질문하실 분 있으시면 마이크 제가 넘겨드리겠습니다. 혹시 질문하시고 싶으신 분 계신가요? No questions? Oh.
So I want to ask a question about how we can use cryptography techniques to integrate AI into blockchain. So I think many projects are trying to integrate AI into blockchain, but the problem is that AI models are too heavy to compute on chain. So we need to compute off chain. But so the problem is that doing computation off chain, we need to some sort of proof that he did the computation right. So we can do that with ZKP, and since we're outsourcing the computation, we need end-to-end encryption. So I think that's where ZKP and FHE can be used. I'm curious what you guys think about those use cases, and is it gonna be possible? Like when is it gonna be possible?
For me, as a ZKP dev, I think it is definitely possible. ZKML, well, I've only thought in the case of like federated learning or something, what like they have this like base model, and like they're training on their own, and like they're updating each individually and like compose it later. But as you said, we need a proof that he did the correct training, right? Well, then that I think is the matter of the front end, like where you design the circuit so that you can properly check like it's trained well, and that when verifying the proof, we can verify correct, like we can be persuaded and we can make sure that if the proof is correct, he should have trained it well. So in terms of that, I think it's just a matter of like how you design the circuit properly so that like there's no faulty training going on, like there's no free rider. And yeah, I haven't thought of like how to design the circuit, but definitely I think maybe with like there are many powerful arithmetizations in the world. So on my take, I think it's possible. You also asked like when. I think it's gonna take a bit long to have a really like perfect project, because there's as I said in the like the keynote before, there are not many like great circuit developers in the world, because it's really hard to audit. It's really hard to like not make a circuit over constraint or under constraint to have the like exact great proof to verify. So I think it's gonna take some time, because like most of the front end, like you write it in Rust, there are not many great Rust developers, and like in conjunction, there's not many like circuit developers in the world. So yeah, I think so, because like it doesn't seem like really impossible to do with ZKP. So that's my take.
Just to add, I completely agree with the federated learning example, but also maybe it's also like a human element of how ZK ML can potentially solve. So like with you need good quality data to train some of these machine learning these ML applications. And if you have the ability to protect user data and privacy in that way, then more people will be willing to contribute that type of data, right? Because, right, even the EU has all these very strict regulation on protecting user privacy and data, and so people are kind of restricting the data. The less data you have, the less accurate or powerful your ML can be. But then, right, with this privacy-preserving technology, you can give people the confidence that their data is protected or not completely thrown or given away, and then you can have more richer data sets. And so, right, you have the ability to give people confidence to have more accurate ML, I think.
Yeah, I think that's it's a good question. I think at least I think like the perfect like holy grail situation would probably using some sort of ZKP to prove that you actually did something, but then what actually does happen would involve FHE in the sense where like, okay, you can prove that you trained on an encrypted data set, but the data was still hidden, or if it's private input, private output, et cetera, or if that's like hiding the weightings and other features of the model on chain, an encrypted set, in encrypted form. So I think these are all options. I mean, I don't know if there's necessarily like one path forward specifically. I mean, like you could theoretically do the private input, private output in a lot of different methods, right? Like I suppose you could send it to some sort of relayer that would send it to some sort of trusted execution environment, and the form of the inputs would be like a ciphertext, and you could use like SGX or something, and sort of just like, I guess, just decrypt it, decrypt the values in the trusted execution environment, run whatever model you need to run, and then pass the output back into whatever network as an encrypted value. But I mean, I think that's just one example, and obviously that has its own security trade-offs, et cetera. But I do think that it probably will like take a lot of different experimentation to see what's going on, and I think it really depends like what purpose do you want to use like blockchain and AI for, I suppose, like in the sense, like, because I think it's very context dependent. But yeah.
Okay.
So I'm curious to know like which manufacturers you think will be the ones that will be like producing majority of the hardware for ZK. Will those be like the current entrenched manufacturers like AMD and NVIDIA, or do you think there will be like new startups that will come out and produce all those hardware?
There definitely is everyone wants to be the ZK, Bitmain for ZK, because like Bitmain, right, over 90, I think it's even higher than 95% of all majority of Bitcoin ASICs are from them. But from what I've seen, there's been so much money being thrown around to basically have the right type of hardware. I think Aleo is one of the earlier ZKL ones that will have like this ZK mining algorithm that people can throw their hardware into. But yeah, right. There's also a spectrum because ASICs are, right, they're application specific, and it's like it's there, and if if the algorithm changes, then that machine's you can't use it anymore. That's why it's like there's a spectrum of, for some of the ZK or the proving, right, there's these things called like multi-scalar multiplication, fast Fourier transform, like some things that GPUs are really good at doing. So right, the spectrum of specialization, I guess, is ASIC is very specialized, GPU is more generalized, and then we have like these like these middle grounds, right, like that people are familiar, like FPGAs, right, like there's some programmability there. There actually have been companies like Superscalar is an example of one that like launched supposedly an FPGA for Aleo, right? Aleo didn't finalize their algorithm, but like, right, but they made that attempt, right, because they wanted to be first to market. There's so many other companies like Supranational, Inganyama, et cetera. There's even networks like Gevulat that recently had made themselves public, where they're literally like aggregating provers, or what we call ZK miners, also provers, that have to incentivize money going to the types of people. But from my perspective, at least from like a ZKL1, where we're managing this new infrastructure class of ZK miners or provers, there hasn't been like there has been, at least in previous testnets for Aleo, a manufacturer that has basically blown everyone out of the water with their type of, but that was very specific to the Aleo Coinbase puzzle, right? That is what, but there might be another ZK one that has their own different type of Coinbase puzzle. The type of trade-off that you have is how generalizable you want to be, but also, right, if you pick the winner and then you have the most specific and efficient hardware, then you win, right? Like if you had picked, I don't know what other POW coins there were back then, but like, right, people who picked Bitcoin and decided to build their ASICs, they won. Bitmain won Bitcoin, right? So I think, but they're right. I don't think anyone has won yet for that. But there's plenty of. I don't think it's private information. I think you just have to dig a little. But there's plenty of manufacturers that are basically like salivating over the opportunity to become the king for ZK manufacturing, and everyone's just going to buy their hardware. But yeah, I mean, there's like, the race has not yet been won yet. Everyone's getting prepared and, gearing up to do that stuff.
I totally agree. For me, I think it's gonna be the end game of NVIDIA, because what Daniel said about like the generality. So from the past Z-Prize contests, I've seen like many FPGA or ASIC projects performing well, but it was very, very dependent on the circuit. Like the input was really, really dependent. So with GPU, but like this is the reason why our team like didn't collaborate with what's the team name? I forgot, but like there were some teams trying to like, if you're doing hardware acceleration, like why not collab? But like to have like the huge market share and like be the winner, I think it has to be general. And programmers can write a generalized and fast GPU code, but like with FPGA or ASIC, when like it's all programmed, you cannot change it, and like it's very, very cost inefficient. So my take is on the GPUs, and especially NVIDIA.
Yeah, and fun, really quick, fact is that Z-Prize is this like open source competition where there's prizes that like Samsung and like AMD have all pulled. Like Aleo was one of the co-founders of Z-Prize. And there was like, I remember there was a bounty for this hardware acceleration bounty. It was like $1 million payout. And there was a bunch of submissions that people had. And then one of the more famous ZK hardware manufacturers was about to submit theirs, but then they pulled it out because they thought that they had like the best solution and they didn't want anyone else to have it, right? Because the goal of Z-Prize was open source it. Everyone kind of, right, rise all the boats together, or whatever. But these guys, they wanted to win, right? They were, right, these very, very competitive guys, and they obviously did very well in the Aleo testnets as well. But yeah, it's the race is that still pretty competitive, and everyone's kind of sharing not too much, but I think we'll see a lot of, because of that, because there's competition, we'll get very, very much more efficient, cost-efficient hardware, which is right what is a great side effect of cryptocurrencies and the incentivization of this type of behavior that we wanted to see. Yeah.
Sorry, one short story to add on. Scroll, they're actually running their provers with like GPU accelerated codes, and I actually met Ye like a few months ago. I really wanted to see their GPU codes open source because they're open sourcing everything, but they haven't still yet. I'm really begging to ask for like, because I think they're doing pretty well, but like we want to start at that point and like collab together, like make great, better results, like faster. But yeah, it's still pretty competitive.
Yeah, the competition is under the water at the moment. So if anyone want to jump in, I guess it's the best time to jump in. Any other questions? No? No one here? Okay. I think that was a pretty good talk from all the panelists. We've been doing it about an hour. So any final remarks from the panelists that you guys want to share? Or if not?
Shill our projects.
Yeah, share your projects. Go Aleo, go FHC, go Kroma. How are we going to shout it?
Yeah. I think like from the point like where I shared the benchmark before in the keynote session, we already like got some like many acknowledgements from like the Ethereum Foundation and like from other teams as well. We're like really on like collab. We're also talking with like Ingonyama and very competitive teams. So we're kind of a like starting a bit late compared to like other teams, but like now we are going I think in the right path. So we'll be keep shilling like with great benchmark results. We'll show the numbers.
Yeah, I wouldn't necessarily. Yeah, I think it's not necessarily a shill, but what I'm really excited about is, right. I've been involved in like all the different types of blockchain, right? POW to POS, right? I ran miners myself. I worked for a large mining pool and validator, but like ZK mining, I see as like a completely separate infrastructure class that may be related more to commoditized POW miners, but then they also have the ability. They have like the latent hardware that can be used for much more than just like solving Coinbase puzzles, right? They can do that. So I'm really excited to see this infrastructure class grow and to be part of its birth and then development and maturation. And I think this is such a great example of how a natively Web3 technology or natively motivated Web3 technology or hardware can also benefit Web2 or outside of Web3. Yeah.
Yeah, I think generally speaking, FHE is pretty comprehensive in the sense that it can pretty much do most things. And if there's probably one caveat to it, is that it is slow and expensive, which is probably why it's only kind of now sort of getting any sort of traction. But to shill, I do think that it is actually it is improving faster than I think a lot to be expected, and it's very optimistic. So if anyone's interested, yeah, let me know.
And you guys are fast to eat soul. You forgot the developers to come there. But anyway, so yeah, thank you everyone for listening, and that was the panel for. Would you guys give a round of applause just a little bit?